Bismillahirrahmanirrahim. Dear students, this is Fayaz Ahmad Chandiya, Professor of Chemistry. Dear students, last time we completed the chapter number 13. Now we start chapter number 14. So grade 12. Grade 12 and chapter number 14. If you see chapter number 14, D block and F block elements. There are 4 blocks in the periodic table: S block or S series, P block or P series, D block D series, F block F series. So if you visit the periodic table, and this portion is given in your book also, so in this chapter we study D and F series, D or F block elements, and they are very important. D block elements are called outer transition elements. F block elements are called inner transition elements. So means we will study transition elements. So first we will see what are the transition elements. What are the transition elements? According to the definition of transition elements, the elements which have partially filled D or F orbitals. Transition elements are those which have a partially filled D or F orbitals, or these elements are processing to complete D or F orbitals are called transition elements. If you see the definition in your book, the elements which have a partially filled D or F orbitals either in their atomic state or in other common oxidation states are called transition elements. They are called D block elements or F block elements. So maybe the simple question asks, why we call transition elements? Because these elements, D and F block elements, show intermediate properties in between. These elements show intermediate properties between S and P block. If you visit the periodic table, these elements are present in between S and P. That is why these elements are called transition. So transition properties, intermediate properties, they are called transition because they show such properties, intermediate properties, which are transitional between highly reactive and strongly positive character S block elements, alkali and alkaline earth metals, which form ionic bond, and P block elements which form covalent compounds just like sulfur, oxygen, carbon, nitrogen, so and so forth. This is the reason why we call transition elements. Now if you see the periodic table, these D block series, the first series is called scandium, Sc. Scandium, atomic number is 21, symbol is S capital C small, scandium. To zinc, atomic number 30, Z capital and small, zinc. This is the third series, from scandium 21 to zinc 30. Second, from yttrium, Y capital and atomic number is 39, to cadmium Cd, atomic number 48, 4D series. Then from the lanthanum, which we call lanthanide series, F block element, atomic number 57 to mercury, atomic number 85D series. So lanthanide series, we are not talking about the F block elements here. Now students, F block elements are starting from the cerium Ce, atomic number 58, to deuterium Lu, atomic number 71, for F series. Number 2 for the F series is actinium, which we call actinide series. So AC89, atomic number 2, Laurentium LR103, which are called actinide series. I told you 5F series. Students, if you see the general outermost electronic configuration for the first series D block elements, first series, so it is N minus 1 and minus 1, then D has 1 to 10 electrons and NS2. This is the general first series D block elements, general outermost electronic configuration. Then second series F block elements, the formula is N minus 1, then D has a 1 and N minus 2, and F has a 1 to 14 electrons and S2. These are the first series of D block and the second series of the F block elements. N minus 1, D has 1 to 10 electrons, and number of shells has 2 electrons. N number of shells minus 1, D has 1, so N minus 2, number of shells minus 2, F is equal to 1 to 14 electrons, and number of shells has 2 electrons. So these are the first series D block elements and second series F block elements. Now, in the D block elements, you will find typical transition elements and non-typical transition elements. Typical transition elements typical transition elements and non-typical transition elements. The question is given in your book, page number 59. Why is zinc group induced in a transition element? Actually, zinc is a non-typical transition element. Zinc is a non-typical transition element. The reason is because if you see electronic configuration of zinc, 2B group, atomic number 30, electronic configuration is 4s2 3d10. Zinc atomic number is 30. So it is present in D block elements, but the question is that why is zinc group included in the transition element? So dear students, I told you zinc is a non-typical transition element because according to the definition of transition elements, I told you the elements which are processing to complete D or F orbitals, but its D is completed with the 10 electrons. See this one. S is complete and D is complete. So this definition is not completed, not fit for the zinc. That is why it is called non-typical transition element. But the question is why it is present in the D block. Reason: zinc, cadmium, mercury, also these non-typical. zinc, cadmium, mercury are not regarded as transition elements, non-typical elements. Because same reason I told you, they have complete their d orbital. Completed d orbitals. It is appropriate to include these transition elements because they form complexes. Other transition elements also form complexes. So these elements also form complexes with ammonia, halides, ions, amines, and their chemical behavior is similar to transition elements. One is a complex formation with amines, halides, and also ammonia, and second is that their chemical properties resemble with the transition elements. That's why they are present in. Otherwise, electronic configuration is not similar. They have a filled d orbital. So this is a reason. Other one is quines. So quines are called coinage metals. They are prepared, they are made from different metals. So these metals are called coinage metals. So these coinage metals, mostly they are transition elements. These may be copper, maybe iron and metal, copper ion, 3d9 electronic configuration, silver, 2 electron loss, positive 2, silver positive 2 has a 4d9 electronic configuration, gold, iron 3 electronic configuration is 5d8. Although all these metals have d10, but in the ionic state they have a incomplete electronic configuration. In d they have a 9, so they can form in the ionic form, and they can form the transition metals. They form the coins. That's why these elements are called coinage metals. Already I told you the position of the transition metals. They are in between S and P. See the table which is given here. In the left side, they are called alkali metals and alkaline earth metals, very reactive and highly electropositive. On the last, you can see the P block elements starting from the boron, carbon, nitrogen, oxygen, fluorine, and neon. So these are P block elements. In between these two, the D block elements and F block elements are called 3B, 4B, 5B, 6B, 2B, 1B, like this one. So they are called B groups. And transition elements, and down you will see the F block elements we call inner transition elements. Now already I have written here typical and non-typical elements. So 2B group. The element of group 2B and 3B have the electronic distribution as follows: zinc 4s2 3d10, scandium 4s2 3d1. So students, cadmium 5s2 4d10, ytterbium 5s2 4d1, mercury 86s2 5d10, lanthanide 57 6s2 5d1. So students, if you see group number 2B elements, zinc and mercury, their D block, D sub-energy level is completed zinc, cadmium, mercury. They do not show the typical properties of transition metals, and they have no partially filled d orbitals. So due to this reason, they are called non-typical transition elements. Do not show typical properties of transition elements. Other one is group number 3, scandium, ytterbium, lanthanide. They do not show many of the properties of typical transition elements. So in the compound state, they show tri-positive ions, scandium 3, ytterbium 3, lanthanide 3. So also they do not show the typical properties and have electron in the d orbitals. That's why they are also called non-typical transition elements. So group number 2B, group number 3B, They are called non-typical transition elements. Group number 2B, non-typical. 2B and 3B. 2B and 3B, these are called non-typical transition elements, and 4B, 5B, 6B, 7B, 2, 8B, 1B, all called typical transition elements. This is an introduction about the transition elements, students. We are talking about the D block and F block elements, outer transition elements and inner transition elements. So now if you see general features, general features of the transition elements, they are all in metallic nature, and there are many transition elements. They play a very key role in daily life, in the industry, and these metals may be titanium, chromium, iron, nickel, copper, molybdenum, zirconium, tungsten, so and so forth. They are hard and heavy and strong, high melting point, high boiling point. They are good conductor of electricity and heat. They form alloys and other elements in the periodic table. Few exceptions, they show variable oxidation states, just like copper has two oxidation states, copper 1 and copper 2. And also there are many other elements. They show also variable oxidation state, iron 2 and iron 3, mercury also. So few exceptions are there. Their ionic and compounds are colored. So if you visit the laboratory, if you see any laboratory and you find the different compounds in the laboratory, and some you will find colorless, white color or colorless, and you will find other colored, maybe yellow color, maybe pink color, maybe red color, maybe blue, light blue, green, like this. So mostly the colored compounds are transition metal compounds. Mostly. If you visit the laboratory and if you open the bottle of compound, so if you see the color, so if you read, so it mostly is a transition metal compound. Maybe the compound of iron, maybe the compound of chromium, maybe the compound of cobalt, so and so forth. So these are the general features of transition elements. So students, there are questions. Already I told you in the previous lectures. So because of you have mostly online classes, means remote classes, so that's why you have to concentrate it very carefully these topics. I don't know about examinations, I don't know about your classes, so you have to concentrate these classes which are going to be online. We started already in the previous session, now we start another second session for you, so concentrate it very well. Write the electronic configuration elements, I told you same. General state of electronic configuration, SPT, this is given also. Names of symbols, electronic configuration elements, this is also given. Discuss strain and variation of oxidation state, valency of transition elements also given. Explain magnetic properties of we will see these properties. And paramagnetism and dimagnetism we have already topic, we will discuss here. Electronic configuration students is given 14.12, which is question is also asked. Scandium, all are given. You have to see this electronic configuration. Starting from 3D1 to zinc 3D10. I told you the zinc is not going to be show typical transition properties. There is one thing very important. Copper. If you see the electronic configuration of copper last 3D10, 1. Actually, if you apply the rule n plus L, and this 3 is a n, 4 is a n, this is a L, and this is a L. And you done in the grade 11, value is 0, 1, 2, and 3. S, P, D, and F. Value of L, 0 means S, 1 for P, D for 2, and F for 3. So if I calculate their value here, 3D. 3D means 3 plus 2. So the energy is 5 for 3D and 4 S. So 4 and plus S is 0. So energy of 4S is this one. So 4S is a less energy and 3D has a higher energy. But if you see the Bohr model K shell. If I say Bohr model K, L, M, N, 1, 2, 3, and 4. So according to Bohr model, 3 is for the M and 4 is for the N. So this is according to Bohr's model. 3 means this is a M shell. 4 means this is a N shell. But according to modern, to calculate the energy of the orbitals 3D and 4S. So 3D has a 5 and 4 has a 4. So first we have to fill 4S, then I have to fill 3D. So when I am going to fill in the routine, in the normal way, I must put 2 electrons in the 4S. Then remaining means 9 electrons in the 3D. S should contain 2 electrons and D should contain 9 electrons. But this is electronic configuration of copper according to scientific, according to research. This is the unstable electronic configuration of the copper. Unstable electronic configuration of the copper. According to rule, means if D is near to filled or near to half filled. Near to filled means if there are 9, or in 3 means N means 1, maybe 2 like this one. So ND. So if there are 9 or 4, this is near to fulfill and this is near to half fill. So according to the scientists, according to the stability of atom, you must fill. Remove 1 electron from the S and make it 10. So there is a 2, so you must remove 1 electron from here and make it 10, the number is same. Same as for here, you must remove from the S electron to the D to make a 5. So please make 5 and 10 if there are 4 and 9. So this rule is only for 4 and 9, not others. That's why if you see the copper star is given unusual and chromium is also given because it has a 3D4 and 4S2. Same this is. Same. And copper is a 3D 9 and 4S2, so must shift 1 electron from S to D to make it half filled and make it full filled. This is very important, you have to remember this one. So the following table, you can see this one, already I told you irregularities, same are given here, I am not going to detail this. Then however, not easy to explain irregularities. There are some other properties for the 5D and 4D and 5D transition elements, since one has to be considered that net effect on many factors such as nuclear electronic attraction, shielding of 1 electron by several other electrons, inter-electronic repulsion, the exchange energy forces. So these irregularities may be effect on these properties. All these factors play an important role together in determining the final stability of an electronic configuration of atoms. So these are the 3D, 4D and 5D series of D block elements and their electronic configurations are given. So So according to the question asked, you have to fulfill this one. You have to fulfill this one. So now properties. If you see the properties of transition elements, so these properties of transition elements, we have binding energies, variable oxidation states, catalytic activities, magnetic behavior, alloy formation. So these properties, inshallah, we will discuss in the next lecture. Thank you very much.